Let's talk about gravitational force at work in our solar system. In this module, we'll be learning about asteroid belts, the inner and outer planets, Earth's satellite, the Moon, Galilean satellites, planetary rings, perturbations, meteoroids, meteors, and meteorites. In Module 7, we learned that the Earth orbits the Sun in an elliptical orbit. So, Earth is going around the Sun in a circular motion. The Earth is orbiting the Sun at about 70,000 miles per hour and is moving very fast relative to the Sun. The Sun, which is much larger than the Earth, is attracting the Earth with its gravitational force. This force pulls the Earth towards the Sun and is perpendicular to the Earth's velocity. So if you see where planet Earth is here, we could actually draw a radius from its circular orbit, and that radius would be perpendicular to the center of the Sun. The gravitational force of the Sun supplies a centripetal force to the Earth. As we demonstrated in Experiment 11-1, the centripetal force makes the Earth travel in a circle. All planets orbit around the Sun due to the gravitational force between each planet and the Sun's centripetal force. So the other planets are also being attracted by this same force. Also attracted to the Sun in an orbital motion and lying between Mars and Jupiter is the highest concentration of asteroids in the solar system, the asteroid belt. The planets of the solar system are placed into one of two groups. We have the inner planets, which is Mercury, Venus, Earth, and Mars, and you can see them lined up here on this figure, Mercury, Venus, Earth, and Mars. And then we have the outer planets, Jupiter, Saturn, Uranus, and Neptune. The asteroid belt lies between the inner and outer planets. The asteroid belt, even though it looks like it divides these sets of planets, is not really the division. The actual division of the planets is because the inner planets are small and mostly composed of rock and iron, whereas the outer planets are much larger and consist mostly of gases such as helium and hydrogen. Each planet exerts a gravitational force on every object in the solar system, and as a result, most planets have objects that orbit around them. The Earth has the Moon in orbit, and when an object orbits around a planet, it's called a satellite. Earth has one satellite, we call it the Moon. As an example, Mars has two satellites, Phobos and Deimos. Jupiter has 60 known satellites. The four largest satellites were discovered by Galileo and are constantly called the Galilean satellites. It makes sense that he would discover the four largest because technology was not as refined when he was working as it is now. He discovered Io, Europa, Callisto, and Ganymede. Saturn, Uranus, Jupiter, and Neptune all have many satellites. They also share in common planetary rings. When we think about rings around a planet, we always think about Saturn because theirs are most visible. But as I stated, several of the planets have rings. Saturn itself has more than 100,000 rings. Each ring is made up of rock, ice, and frozen gases. Uranus has at least 13 rings, Neptune has 9, and Jupiter has a series of rings first discovered in 1979. The rings on all of the planets except Saturn are recently discovered, and new rings are being found as technology advances. Let's talk a little about asteroids. Asteroids are present in the solar system, mostly between Mars and Jupiter. Asteroids can range in size from the largest at like 900 kilometers to the smallest, which could be as small as a tiny grain of sand. Remember insolation? Insolation, we learned previously, is the energy from the sun. The planet Mercury receives the most insolation from the sun because it's closest to the sun. Though you might expect that Mercury would be the hottest planet, it actually reaches temperatures of 750 Fahrenheit during the day. It also happens to get really cold at night at about negative 300 degrees Fahrenheit. But Venus is actually the warmest planet with a constant temperature of around 860 degrees Fahrenheit. So if Venus is farther from the sun than Mercury, then why is it hotter? Well, Mercury has a very thin atmosphere. Venus has an atmosphere made of almost entirely carbon dioxide, greenhouse gas. So Mercury's atmosphere cannot hold heat, but Venus's atmosphere can because of the greenhouse gas effect. That effect traps the energy it receives, creating a very regular temperature, just like what happens here on Earth. There are a lot of gravitational forces in the solar system. Because the sun is the most massive object around, its gravitational force is the strongest. The sun's gravitational force exists between every other object in the vicinity. Each planet and asteroid also attracts every other planet and asteroid. Gravitational forces can cause small variations in a planet's motion. This is because the sun is not the only object that's pulling on the planets in the solar system. Each planet is pulling on each other planet, and they're in constant battle with these forces. So these variations in a planet's motion or its orbit are called perturbations. The study of perturbations led to the discovery of Neptune. Perturbations affect asteroids with very dramatic effects. This makes sense because asteroids are much smaller than the planets are. When asteroids' orbits are perturbed enough, they can be thrown out of their standard orbit toward a planet. Many asteroids are flung towards Earth, as an example, and when intersecting Earth's orbit, asteroids are called meteoroids. When asteroids hit Earth's atmosphere, they experience large amounts of friction due to air resistance. Consequently, asteroids heat up to high temperatures. And the white-hot asteroids, then, which often appear as streaks in the sky, are referred to as shooting stars or meteors. The intense heat usually breaks up the meteor. Any pieces of the meteor that escape the heat usually fall to the ground, and they are called meteorites. Most meteors burn up when they interact with Earth's atmosphere, but there have been exceptions, and very large meteors can survive hitting the surface of the planet with great impact. On Earth, most evidence of meteor strikes has eroded. However, on other planets, the scars of meteor strikes are very evident. So you'll have, if a meteor strikes, initially it'll have a burn area around it, and then it will create, the impact will actually create a crater. And up in Oregon, a perfect example is a lake there that's called Crater Lake. But Arizona also has some very clear marks of meteor strikes that you can go visit. So if you have any questions on this module, go ahead and contact me, and we'll be moving on to the next video.